Hello everyone, welcome to this video, the number of smallest unoccupied chair. So in this problem, you receive as input um, an array of array where each of the elements is actually the arrival time and the leaving time. So that means this guy is coming at time 1 and is leaving at time 4. And what is happening is you are supposed to find what is the chair that a given friend is going to occupy. Let me take this one as example. This one is coming at time 1 and is leaving at time 4. This one is coming at time 2 and is leaving at time 3. This one is the first one to arrive, so it's going to take chair 0. This one is the second one to arrive, so it's going to take chair 1. Our target is actually the guy arriving at is actually the second guy, which is this guy. So this guy, since he's going to occupy the chair 1, we return 1. Why is even this guy occupying chair 1? Because the instruction is that whenever you're arriving, you need to occupy the smallest unoccupied chair. That means if this one is arriving at time 1, for instance, and leaving at time 2, and this one may be arriving at time 3, is going to occupy the chair 0 because this one left already and the chair is actually free. So that's the idea behind this. Let me get this as example. This one's an interesting example to understand how it's works. Uh, this one is arriving at time 1. So it's taking chair 0. This one is arriving at time 2. It's taking chair 1. This one is arriving at time 5. But at time 5, those two guests are left already. So the chair 0 and 1 are going to be free. So this one is going to take chair 0. So if you want to track the position occupied by our second element, that means 0, 1, 2, our third element, if you are one base, then we are going to return 0 because at the arrival of this guy, those two are actually empty, so he will be able to take chair 0. Now, how do we solve this? So I will share with you two approaches for solving this. This approach is actually an approach I took from the editorial, and after this I will share my thought process, how I approach the problem, how I solve it. So for this one, the idea is simple. We are going to sort the element. That means um, we want the one arriving first to be handled first, which is actually logic. You can't pretend to um, you can't pretend to have to implement the flow with just. So the idea here will be as simple as this. First, we want to sort our guest because we want the one to arrive first being uh, proceeds first. That means if I'm coming before you, eventually I'm going to take a seat before you, right? So that's why I want you to be at the beginning of my array. That's why they are sorting here. And one thing interesting is that two people cannot arrive at the same time. So if I keep track, why am I saying that? Because the arrival time is actually distant. So if I'm saying, okay, if my target friend is actually 1, is actually 0, keeping the time that the friend is arriving is enough for me to be able to know the position or the chair I will give to that guy. So that is why here I'm keeping a target time, which is the arrival time of my friend. Okay, and this is the idea for each of the friend, right? I will look all of the chairs and I'll find the first chair which has a user with a time less than my arrival time, and I will sit there. That means by default, when you are creating a vector like this with no element, they are actually 0, 0, 0. So I will check, this is the first one, is there anyone with a time, in fact, is there anyone that will leave the chair before my arrival time, which is 1? Yeah, the first one, because it's actually 0. So I will put this one at position 0. Now, what am I putting at position 0? That is really important. I'm putting the leaving time. That means after 4, someone can still occupy the position 0. So at chair time 0, I'm going to put 4. Now I'm going to loop again. I'm going to check the first element with leaving time actually less than less than my starting time, which is 2. And the first one will not be okay because the first one is actually 4 at this time, and the second one is actually 0 because it's the default value. So this one is going to occupy the second chair, which is chair 1. Now when I will start, I will take this one, I will check, I will start back from 0. That's why I have a second loop here. I will loop from 0 till n, and I will say I will check what is the chair that I have with a leaving time less than my starting time. This one actually match because this one is going to go at 4 and me I'm going to enter at 5, so this time is actually less than my starting time, so I'm going to occupy this chair. So that's why having these 2 loop here is actually enough to satisfy this problem. And then what is the breaking condition? Since we are keeping the time where I would say our target guest is actually coming, so whenever we are going to meet the guy with a time equal to our target time, at that time we are going to return I. So that is why we took it here, because we wanted to make the comparison based on the time. So this is the logic of this, and it's actually working pretty well. So it's performing pretty well. You will see it's working. So my solution, what I came up with when I was working, is a little bit long, but it still makes sense, right? So the idea is different. So my logic is a little bit different. It's a bit longer than the previous one, and performing almost the same. But I think there are things we can improve here. But the idea here was, I have like a list of empty chairs. That means this is the list of the available chair that can be used empty. I'm using a set because I want to keep them short. I have a map of living. That means, okay, at a given time, those are the chairs that are going to be empty. And then I have a map of arrival. That means at a given arrival time, this is the chair that will be occupied. So that was my logic. So the same as those guys. So I took the time of my target friend, and I create a variable next. That means this is the next chair that can be occupied. The idea is that if I have any empty seat, definitely we are going to take the smallest empty seat. If I have no empty seat, the chair you are going to occupy will be this next. So this was my logic. And I first initialize my arrival time. That means for each of the element in the time, I say, okay, the arrival time I said, yeah, this is it. So the arrival time of actually my element 1 correspond to 4. Oh, so this is not even the arrival and occupy, this is the arrival and leaving. Okay, so you are coming at position, you are coming at time 1 and you'll be leave at time 4. So this is what this is about. And then now after that, this is my idea. This is maybe the heaviest part of my logic, because I'm looping from 0 till t. That means, like for instance here, since the target is actually 2, because the target is the time of our target friend, so I will loop from 0 till 2. And while looping from 0 to 2, for each of the element I will take, okay, at that position, do we have like empty, do we have people living at that time? If you have people living at that time, I would take their seat. I mean, because this is the place they were occupying, I would take all of the place they were occupying and I will put them back in my empty seat for the available seat for the next people. I'm doing this before because it has been said here that a user can leave its seat and another one take the seat at the same time. So if you are leaving at 4 and I'm coming at 4, I can take your seat. So that's what I'm doing here at the beginning. After now freeing those space, I will now check, do I have someone arriving at that time? If I have someone arriving at that time, what I will do is that I will check if my empty seat is actually equal to 0. That means there is no available empty seat. All of the previous seats are actually occupied, so you are taking the next, that means this guy, and I'm incrementing my next. If I have empty seat, you are taking the first empty seat and I'm erasing that empty seat in my list of empty seat. And at the end of this, I need to say, okay, this guy that just coming is going to leave at this time, because this is actually that means the guy that just enter the guy that just coming arriving at the given time is going to leave at this time, and this will be actually useful back here when we are going to reach that time. We are going to free that space. So this is my logic of solving this. It's also working pretty well, and it's performing almost the same as the previous one, even though I thought using this may be a good option, maybe nice, but yeah, we are almost the same. So this were my approaches of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new challenge. Don't forget to like, share, and subscribe. Ciao.